provided you with the valuable learning experience, allowing you to gain practical knowledge about the functioning of various machines in healthcare, with providing you the significant role of our research that in medical imaging plays its role in the context. So I thank our professor, Dr. B.S. Shekhar sir, for providing us an opportunity like this with planning such a well planned event with theoretical experience, practical experience, as well as live practical exposure with the industry visit. So now we have a technical session by a dynamic personality of Computer Science Department, the chairperson of Computer Science Department, Professor H.L. Shashireka Madam. She is I'm proud to say that she is my teacher during my MSc course, and she is very dedicated teacher, I can say, because whenever we were free during that time, she used to come and ask, are you free? And she used to come and take data structure classes always, maybe the maximum number of classes she has taken. So, ma'am's a brief, very brief. I have made it very short. She said not to read it out. So, but still, I have to read something. So, ma'am has completed a PhD under Murali sir from Mysore University. She has successfully completed 2 PhD students, PhD scholars, and 7 are currently pursuing PhD. She has also successfully completed a UGC research project. She has published more than 50 research papers in reputed journals and indexed conferences. She is an active member of many professional bodies, including academic bodies like BOS and BOE. Her research interests include natural language processing, machine learning, and data mining. Thank you, ma'am, and I welcome you. I also welcome all the participants and FTP coordinator, everyone present here. Over to you, ma'am.
Hello. Yeah. Thank you, Bharti, for the introduction. I also take this opportunity to thank my colleague, coordinator of this FDP program, Professor Shekhar, for giving me an opportunity to share my a little experience, whatever I have. I feel I'm an odd woman out here. All of you are, have done so much research in medical image processing, or maybe even image processing, and then medical image processing. But I'm still a beginner in image processing, forget about medical image processing. I'm now learning ABCD of image processing. But I feel that I know ABCD of text analytics, and that's why I stand here to share my knowledge about text analytics. Okay. Before you started medical image processing, right? So all of you have worked on image processing. Let us say the initial days of your medical image processing, right? Most of the time, at least what I think is, we remove that medical part and think that as an image processing part. And once you get some knowledge over that domain, then we try to incorporate that medical part, so that now we can say that we are working on medical image processing. I think all of you agree with this, okay? So I would like to do the same thing here. I would like to give a brief introduction, or it's like an exposure of text analytics. We can call it as text mining, NLP. We'll see why all those definitions. And then we'll add the NLP for medical data, or healthcare data, health analytics, clinical, etc., etc., etc. So first we need to have the challenges of general text processing. What is text processing, what are the challenges, what are the tools, etc., etc. And then I'll try to include this NLP for medical data or the clinical data. Okay, this is quite a topic which everyone knows. Recently, Rashmika Mandana was on news because of the deep fake video, right? Deep fake. Let us not worry about deep. So fake video, right? So like this, there will be so many fake articles on Facebook, because Facebook or any social media app, you know that it spreads within no time. It gets viral immediately. So in addition to the advantages of these social media apps, many of the culprits they are using for, or you can say they are misusing this opportunity, and to misuse that, again these social media apps are contributing in a sense the anonymity of users. Anonymity of users are used by the culprits to spread this fake news. Right? This is one example of fake news. This is another example of fake news, especially this fake news which we all might have seen during the COVID days, right? If you want to buy let us say in our generation, if you want to buy a laptop, forget about laptop, at that time laptop was not there. If you want to buy a phone, or if you want to buy an electronic gadget, or whatever it may be, right? What we used to do is, we used to ask our friends, we used to ask our siblings, we used to ask our parents, and then decide whether to buy or not. But now, maybe for some of the youngsters here, or if you, for the parents who are here who are having kids, now the scenario is different. If you want to buy a laptop, what we'll do? Check Google. We have the Google God now, right? Check Google. So compare the reviews, compare the prices, compare the configuration. If you want to watch a movie, what we do? Check the reviews. Check the reviews, see what is the rating for that review. If you want to do online shopping, so what will you do? Again, check the reviews, check the ratings. So putting all this together, now we are in the era of online. So whatever we want, we will try to check the opinions or find the opinions of others, find the reviews about the, it may be about the movie, about even buying a small item online, or you can say online shopping, or it can be sentiments. Let us say you want to watch a movie online, check the YouTube, check the comments, or it may be a video on YouTube, so check the comments. So we are living in that era, we can say. So what is the opinion of others? So that's where we have opinions, reviews, and sentiments, right? So if you look into the word cloud or the text cloud, I can say, so these are some of the words that is used, like text mining, then it may be machine learning, information retrieval, social media. You can go on listing these words in the word cloud. So these are few scenarios which we can see. For example, homophobia detection of YouTube comments, bias, threat and aggressive identification. It could be event detection, it could be multilingual news article similarity. I mean, you can again go on listing. This is quite old. This I had prepared, I think, some 2-3 months back. Now our own students, they have found some new topics which they can work on. So you'll have a long listing of this which you can see. And why all this, or why so many of this? And we have a major contributor, and the major contributor is social media, right? And in the difference between the conventional text and the social media text is, in social media is like it is open for free. Anytime, anyone can post anything. There is no strict rule, there is no moderator. So anybody can post anything, and that has resulted in so many things. Say if I want to talk ill about someone, so I can post something ill about that person on Facebook, or I can tweet, or maybe I can post it on Instagram. So there is no content moderator. So mainly because of the social media platforms, now lot of user generated content is available, or users are contributing. If you want to write a news, then first of all you have to prepare that news clipping, or you have to prepare that news article. Maybe you have to take the permission of your HOD or your principal or whoever is the senior. Then you have to send it to the press, any of the newspaper. They also will check the content, and then they'll post. But in social media, it is not the case. The moment you want to post anything, within no time, without a second thought, you can just post it without even understanding the consequences. And that has resulted in so many applications. Yes, what is common to all of this? All this is this text. Right? The word text is important in all this. And this text is one of the unstructured data. Why one of the unstructured data? There are so many unstructured data, right? Any other unstructured data? Is image an unstructured data? Video? Signals? Okay, what do you mean by structured data? Anything that fits into a model. This text does not fit into any model. Image does not fit into any model. Any data that does not fit into any model is called as unstructured data, and text is one such unstructured data. And these are the resources of text. It could be social media text or the conventional text. So these are some of the sources like email, news articles, digital libraries, transactional ERP, then you have social media data, of course, then call detail records, web logs. Again, you can go on listing the sources of text data that is available. Here again I have listed some sources of text data. Your email is there. In fact, if you open your smartphone, there itself you can find different types of data. You have you can access Facebook, you have access to WhatsApp, then you have access to your mail, you can access Google, so that you can have a look at the news. So these are all examples of text data, right? So what is the motivation for text data processing? You list out all possible types of data on this earth, right? 80% of that data is unstructured data, right? And if you say 80% of this unstructured data, I am telling 80% of the entire data is unstructured data, and if you take 80% of that unstructured data, and that 80%, 70 to 80% we can say that is text. And text is present everywhere. And that is the reason why lot of people are motivated to take up this text data processing. So these are some of the examples of structured data and unstructured data. The main difference between structured data and unstructured data is structured data will fit into any model or the data generated by any model, but unstructured data does not fit into any model. Okay, if you list out some of the tasks involving text data, these are some of the tasks I said, not the exhaustive listing. You have information extraction. What is information extraction? Let us say you have received a mail from your institute. Now you are on a, I don't know whether I can say vacation, but you are on, or you can even say you are on official work, or you are attending the FDP. You have received a mail from your office, from your institute. So do you have time to read that entire mail? Maybe it is about information about a meeting. So what is that you would like to capture from that mail? What do you want? You want when is the meeting? Where is the meeting? What time is the meeting? Right? We want date, time and venue. Maybe who is organizing the meeting? That's it enough. So instead of that big mail, suppose if someone sends only this much, date of the meeting, time of the meeting, venue of the meeting, or maybe the purpose of the meeting also, right? So that is more than enough. Now, given this email content, can you templatize this? Right? Can you templatize this? Head of the department or chairperson of the head of the institution keeps getting so many mails like this, right? And definitely the head of the institution will not be having time to read all those mails. So he or she will ask the secretary to brief that. So what the secretary will do? What I said now, templatize. Give the date, time, venue. If you look into the principal's chamber or chairman's chamber, so they will have a board, a notice board, and in that notice board they will have columns. Date, time, which meeting is that, and maybe who is organizing, where is the meeting, fine. What are we doing? We have templatized. We have input to the information extraction is the text data, and out of this text data now we have the structured data, and that structured data, whatever algorithms that you can apply on structured data can be applied on that structured data. So information extraction. In fact, when I started my PhD, I thought of working on information extraction, but the problem was my vocabulary was not matching with the sir's vocabulary, Professor Nagbhushan sir's. He was telling something and I was understanding something. So it took more than 6 months to arrive at a point and then continue the work. And there I missed this information extraction and I had to take some other topic. Text classification, here I mentioned these topics, and many of these scenarios, they belong to supervised learning or the text classification, or we can say they can be reduced to the text classification problem. And I did not have to explain about the classification part, but classification applied to text we will take it later. Then clustering, why clustering? Yesterday when Chandrasekhar sir was explaining, I said, can we use clustering for this? And even when Dinesh was explaining, he asked how to get the samples or how to reduce the data, how to reduce the samples. So how to reduce the samples? We can cluster. So cluster the samples. So similar samples belong to a group. Instead of all those samples, you take a representative of that sample. So we are reducing the number of samples. The same thing can be applied even to reducing the features. So text clustering can be done, and an important aspect of text clustering is most of the text data is not annotated, right? Most of the text data is unlabeled. You will have text data. So you always post comment on YouTube. You post or you comment, you send your reviews, or you can post your opinion on Facebook, Twitter, everywhere. But who is going to annotate? I mean, someone has to do that job. So if you want to work, then it is your headache to annotate. But is there any other way where you can annotate? So text clustering can act as a pre-processing tool. I mean, clustering can act as a pre-processing tool for classification. Here this is a special case where we can think of applying clustering for the text data, so that you can prepare the labeled data and use that labeled data for classification. Because one point that you have to remember in any classification step is, without labeled data, don't think of classification. You need a labeled data. So if you remove that labeled part in your data, then it becomes unsupervised data. It is not a supervised data, right? Text summarization, right? So my example for text summarization is something like this. So the World Cup cricket fever is gone now, right? Let's go to library one day, take 1 day's newspaper, right? 1 day's newspaper. Then you collect all the articles related only to this World Cup cricket, and can you give me a summary? Because our library may be having some 10-12 newspapers, and I don't have time to read all those 10-12 newspapers. So can you get, I may ask one of the student or maybe the person who is sitting here to give me the summary, right? Can we do that? This is one. So we are using multiple documents. So multiple documents and getting the summary. Instead, let us say I'll stick to only one newspaper, right? The day the World Cup started till the day it got over. So can you give the summary? Again, we have multiple documents. Taking only one language. Can we have multiple languages? We have Kannada newspapers also. So can we have both English and Kannada newspapers and get the summary? So we have multilingual document summarization. So multilingual, cross-lingual is quite common in text, but this multilingual and cross-lingual part you may not find in okay. So this multilingual or this cross-lingual, I don't know whether you can find in text, any other type of documents. But in text document, we have all this cross-lingual information retrieval, multilingual information retrieval, bilingual information retrieval. These are quite common in text data, right? Word sense disambiguation, right? I'll say today I had been to Enapoya hospital. For what purpose? I mean, if I just say today I had been to Enapoya hospital, so nobody knows for what purpose I had been there, right? So word sense disambiguation. So word, for example, I say I had to go to bank. Which bank? Right? I love chicken. Chicken as a dish or as a bird. Right? So there are so many such words which have multiple meanings. Right? Then cross-lingual or multilingual information retrieval I mentioned. Multilingual information retrieval, I would like to give the query in Kannada, and I want the documents in Kannada and also English, right? Or I'll give in some other language. I want it in some other, in general I want to give it in source language, and I want the documents in target language. So multilingual information retrieval. Then there are other tasks like named entity recognition. Named entity recognition is a problem which comes under information extraction, or if you restrict the entities here to named entities. The entities that has to be extracted to named entities like name of a person, name of an organization, the location, date, time, those things. Then we have named entity recognition, recognizing the named entities in a given text. Or it could be part of speech tagging. Part of speech tagging we started learning when we were in high school. The 8 basic tags, right? Can we tag each, suppose if this is the, if this is the sentence, can we tag each of these words with a tag, or each of this term also we can say with a part of speech tag. Then we have word level language identification. Some of these tasks, or I can say like hope speech, hate speech detection, fake news, or here I have introduced language identification, here I have written word level language identification. These are because of the social media data. How do you send a message to your friend? In WhatsApp? Do you say, I am in Mangalore University attending a FDP? Using, like an email sending to your principal? No. Use short forms, right? And that short form will be understood only by the other person, right? So it is something like a coded language, right? Something like a coded language. The other person cannot understand. If there is a small kid at home, the vocabulary of that kid will be understood only by the mother, then the other members of the family, right? The outsider cannot understand. So the vocabulary of one child is not the same as the vocabulary of the other child. So social media data is something like this. So this has introduced this word level language identification. Why we need word level language identification? If you identify the word language of that word, then you can apply the normalization techniques, and then see to it that it can be converted, it can be translated to any one language, so that the tools of that language can be applied. And word level language identification, or the social media text. Social media text has introduced another problem, and that is normalization, right? When Professor Nagbhushan sir said, I worked on matching problem, right? He had given me nearly 3 to 4 months to study the data, right? Most of the time when my students come, I say, you read the data, see what are the patterns, try to understand the patterns. What is there in the data, you find out that. What kind of algorithms you can apply, that comes later. But first you have to understand the data, right? So it was the matrimonial data we were reading, and most of the time I used to sit with professor's wife, Lakshmi madam, who had come here, and we used to read the data, because she also was interested, just to, just curiosity, what will be the, whenever they give their expectations, wanted bride, wanted groom. So when we were reading, one word was, is useless, right? Then she said, Shishi, who will say I am useless? Why this person has said useless? Actually it was not useless. And why I am telling is the normalization problem, right? It was one word, one character, is useless, issueless. Issueless is useless, right? And most of the time in our school, one headmistress was there. She used to say, you useless child, you useless children. Every time she used to say, you are useless. Then one day the students, they rebelled and they said, madam, not madam, miss, or maybe teacher, please don't say useless. We may be less useful, but we are not useless. Right? So there is lot of difference between useless and less useful. So nobody is useless. They may be less useful for that work or for that objective or for that purpose. But nobody on this earth is useless. So lot of such things are introduced by the social media data. So normalization is required to a large extent. For example, I say, I didn't mention that. I didn't mention that. Didn't is a word that we use in our spoken language, right? D-I-D-N, sometimes we put that T. But when you are sending a WhatsApp message, we don't even put that quote. I say D-I-D-N-T, didn't, right? Who will understand that it is did not? We will understand, right? Can the machine understand? They are called as contracted words. So we have to expand those words. So like this, there are lot of normalization. How many of you write GM for good morning? How many of you write 2MW for tomorrow? Right? These are all the internet slangs. Can they make these internet slangs? So normalization comes into picture. Right? So social media data has introduced lot of problems, especially problems for text processing. And now because we know social media platforms are increasing day by day, social media users are also increasing day by day. So now the default language has become the social media language, right? Or you can say it's a WhatsApp language or a Facebook language. So we have accepted that. So sometimes our students say okay. Sometimes they don't even write O, they write K. So I have to understand that they are saying okay, right? OKAY has come to okay. That remove that O, now it is only K. I do not know tomorrow what they'll say because madam they have removed D now, right? Yeah, MAAM and sometimes it MAM, right? So MAM is fine. But if they remove the last two letters and if they say only MAD, then the problem starts, right? So, I mean, you can think of lot of such examples. Okay, another example that I have not introduced here is machine translation. Almost all languages have this daily soaps, daily TV serials, right? And a snippet of that serial is available on Facebook, some 2-3 minutes, I think, right? And above that snippet, there will be a translation in English. If you have not watched those, what is that? No, I'm not interested in the serial part. The above, they'll write in English, they'll write in the local language, then that will be translated to English, right? You have a look at that translations, right? Ugrappa, I mean, everyone knows Ugrappa. Ugrappa means Ugra, something related to terrorist, right? So Ugrappa will be translated to terrorist. And who is Parmeshwar? Parmeshwar is God. Then today the boy who explained us in the dermatology department, his name is Parmeshwar, he was our student, our MSc student. So we have to call him God. So like this, I mean, it will be very funny to watch those. So Parmeshwar was our deputy chief minister maybe in the earlier government but he was there in some government. So, I mean, when we translated that, even using Google, it says Parmeshwara will get translated to Lord. And when it comes to translation, you'll get lot of such examples. I mean, out of curiosity, you just watch the transliteration of the local language of local, transcript. Transcript will be not more than 2-3 lines in English. You watch that and you'll get lot of funny examples. And as I said, this is not the end of this. There are many more such examples. Okay, so these are some of the examples I mentioned. So, bat, are you referring to this bat or this bat? Right, when I say apple, right, when I say apple, maybe if high school going children are there at home, they may not be interested in this apple. They may be interested in this apple, right? Bat, this bat or this bat. Definitely in the cricket season, if I say bat, this will be the bat, right? So how do we resolve this? That is where we have word sense disambiguation. If I say I am going to bank, I am going to bank does not convey whether I am going to a blood bank or I am going to a river bank, right? Or I am going to a bank which is in our campus. So context is required. So context plays a major role in word sense disambiguation. Sentiments, is the movie great? I say how was the movie? Okay, how was today's industrial visit or visit to Enepoya? Good. Anybody who says okay? Okay, let us say Bharti says okay, you tell me okay. How was it? Okay. So what does it mean? Was it good? Okay, some of you may say no, it was useless. Fine. Right? So here onwards you make the difference between useless and less useful. Less use. Okay. So some of you may say not good, some of you may say very good, some of you may say good. Bharti said okay. Good is fine. Not good is fine, but what do you mean by okay? Is she not happy with it? So okay, does it say positive sentiment? How was the movie? How was the movie? Okay. And if you say okay, your friend need not have to say okay. She may say good. Right? It is subjective. Right? It is subjective. It depends on an individual. Right? So we may have positive sentiments, negative sentiments, neutral sentiments. If you want binary classification, then you will have positive sentiment and negative sentiment. If you can extend, then you can have minimum three. Positive sentiment, neutral sentiment and negative sentiment. Or we may add some more to this, and there is no restriction on how many sentiments you can add. You are defining a multi-class classification problem. So this can be considered as a multi-class classification problem. Even word sense disambiguation can be solved as a supervised learning problem. So machine translation, which I already mentioned. So translate from source to target. What is source and what is target? Source can be text, target also can be text. Source can be text, target can be speech. Source can be speech, target can be text. Source can be speech, target can be speech. Can source be text and target can be image? I mean, we may not call it as machine translation at that time, right? So given a text, output is an image, right? And we see or we have experienced this only in maybe movies or serials where victim, someone from the victim side will come and describe the person, and there will be a, I don't know what that person is called as, and he will sketch, right? He will sketch that person and he shows whether he resembles this person, right? Long back, now I do not know, long back in Sony TV there was that CID serial. Every maybe Saturday or Sunday, or I don't know whether every evening it was telecasted, and there were some three important characters. So one guy got I mean he did something, and so they called the family members who was the witness, and that witness says give some features, and he draws that, and they were not able to trace that one. That was because he took the features of eyes and maybe hairstyle from another person, maybe some other components from the other person. So all three put together, now it was an image, right? Okay, so I mean, but this is possible. You can sketch based on the descriptions. Okay, the other one is, can input be the image and output be text? We have image captioning, paragraph captioning, right? Can we describe that scene? Can we build a story? So given some characters, especially if there are some kids at home, young kids, so they will give some characters and we have to weave a story, right? Now language modeling is there, so weaving a story or generating a story is a reality. It's no longer a dream. So how many of you have read Phantom comics? Yes, only one. The youngsters may not know what is Phantom comic. So when we were children, school going children, in the newspaper they used to come this phantom. If you get a chance, you see. And at that time, whatever video conferencing we are doing, so it was there, but not with the name video conferencing, right? Even, and it was those days when there was not even phones. So in that comics, those phones were there. So if you get a chance, you see that phantom comics. Right? So you can think of various source and various modality for source and various modality for target. But if the source is text and output is also text, then we can have from source to the target, and that is called as machine translation. Not only that, can we translate the social media data to the target language? So source need not be in one language, right? Source can be in the broken language. The broken language like the social media data. Can we normalize that? That can also be a machine translation problem. So social media again has introduced another problem. Right, question answering. How was the movie? How was the industrial visit to Enapoya College? Yes or no? Or good, bad? So binary, yes or no you can say, right? Or given 4 objective type answers kind of thing. So you may have to select anyone. Or instead of this you may want to describe, right? Describe a bit about your visit, right? So the question in natural language and answer in natural language. Have we done this question answering during our high school days? Yes. What was that? Reading comprehension. So in English, even any language, they used to give a paragraph and questions about that paragraph. So you have to answer reading that paragraph, right? So what is there in reading comprehension? That reading comprehension part is automated now, and it is called as reading comprehension. And Stanford University has got a very big big data set for that, right? That is closed domain data set, closed class data set. And the other one is open class. This is the open class, right? Who is the man of the match for last cricket game that India won? So this is the open class category. Summarization I already explained. So named entity recognition. See here you can see. Open is given like this. I mean, I can ask anything, any question. You should be able to give an answer. So closed is, it's confined to, reading comprehension is a closed class, not an open class. The knowledge base is very limited. Okay, here you can see, this is a name. Here, weather underground, Irma. So we want person, organization. Here you can see Cuba, this is the location. So ultimately what we want in this piece of text, we are interested in Jeff Masters is a person, Weather Underground is an organization, Irma is a person, Cuba is a location. So if you want to further identify the numeric values, here we have 5, here we have 3, here we have 20, that can be identified. It all depends on the application that you are having. Right. So we have seen several examples for text. Now we can say text processing, right? But if you look into the literature, there is text mining, text analytics. Text mining is a old terminology, right? Earlier, when data mining was there, so data is, when you say data mining, it acts on any data, right? But if it is on text, then they used to write in brackets text, data within brackets text mining. That was because computers were originally invented for number crunching, not for string processing. But later, computers were also used for string processing. At that time, within brackets, text mining, data mining, then they used to write a text. And after some time, they used to say text mining is a subset of data mining, right? And text mining was evolved. And under text mining, there were so many other topics of research. But now, text mining is no longer used. Right? Data analytics, health analytics. Similar to that, we have text analytics. Then what is natural language processing? I mean, there is no clear definition, difference between text mining, analytics and natural language processing as long as the the definitions that are available are concerned. So some definitions say natural language processing uses text mining. Some other definitions say text mining uses natural language processing, or text analytics uses natural language processing. But one thing that is clear is, when you say natural language processing, the language component is there. But in text mining or text analytics, that language component is not there. I mean, language component is not mentioned here. So we'll come to that. What is language component? Why language? What do we do with language? If you remember, when I said about machine translation, I mentioned about image, I mentioned about speech, I mentioned about text. What is language? Language is the medium of communication, right? How do we communicate? We speak to each other, right? We write letters, we write message, right? Recently I had been to JSS Polytechnic, and that JSS Polytechnic is for that deaf and dumb school, physically something challenged. Not physical disability, but this one, they cannot speak and they cannot hear. Entire campus was silent. I mean, when we enter, we almost feel that nobody is there. But there were students, and I mean, everything was going on normal. Only thing is, because they cannot speak, right, there was no galata, there was no sound. How do they communicate? They have the sign language, right? Any other medium of communication? Any other medium of communication? No. No other medium of communication? Does silence communicate? Does silence communicate? Yeah, it has. I mean, silence is a very powerful means of communication. Depends upon the time. It's a very important means of communication, right? So, in a hostel, 2 girls or maybe 2 boys also, they were staying in one room. They had fought. So one girl wrote a cheat there. Please wake up tomorrow at 5 o'clock. I have to study because of the internals. Okay. Next day, that girl, she woke up, the other one, she woke up and she wrote a chit, please wake up, it's 5 o'clock, you have to study for internals, right? And she slept, right? Silence means of communication. So she had, first girl has written a chit, so second girl also wrote a chit and she slept, right? So silence, conveys lot of meaning, right? Okay. So, natural language processing. Why natural language processing? Because it involves language part, and natural language processing does not deal with only text. Natural language processing deals with any language that is used for communication. It could be speech, it could be text, it could even be the sign language. Any language that is used for communication. And when you say natural language is the language that we human beings use to communicate. How do we communicate? Of course, if there is any way to express silence, maybe that also can be considered. How do we express silence? That also can be considered under natural language processing. Otherwise, what is natural language processing? It is to communicate between human and machine. So let us not go into the definition of this. Yes, how do we convey emotions? Right? Whatever is the language that you can communicate. How you communicate, right? Most of the time we may not be good in writing letters, good in dropping a mail to our principal or our seniors, right? In such cases, we write, right? Even when you are sending even on WhatsApp, some people, they'll record the voice and they'll send. Some people write. Why? Maybe they find it difficult to write, especially when it comes to Indian languages. It is difficult to write Indian languages, whether it is your phone or your laptop. But voice, it could be in any language. You just record the voice and it can be sent. Okay, but one point about natural language processing is it has got 2 components. One is natural language understanding, the other one is natural language generation, right? I don't think there is anyone who doesn't know about Siri, Alexa, Google Assistant, right? Siri is a very good name, right? So, I mean, if kids at home, they most of the time they use this Siri, Alexa, just to have fun. And don't you think that all this Siri, Alexa, they are pushing us towards laziness? I mean, we are so lazy. We have the smartphone, but we do not want to search for the name and then make a call. We'll ask Siri, call this. Siri, call that number. Siri, call this person. Right? So, natural language understanding. What do you mean by natural language understanding? So, these two, natural language understanding and natural language generation, they are trying to mimic the human capacity to understand language and generate language. So, if I say, Siri, call Shekhar. So, if Shekhar's number is there, then there will be a call. I do not know what happens if there are two Shekhars in my name, two Shekhar names are there. I do not know to which it calls. I have not used so far. Last, okay, maybe. I mean, there should be some strategy. Maybe. I mean, there should be some strategy to resolve this, but definitely there will be some strategy. Right, Siri, Alexa, Google, all this. Natural language generation. What is summarization? Takes today's newspaper, you have to write, right? You have to write a summary. You have to write a summary, write the abstract. Yes. So you have to generate the data, right? You have to generate the text data. What is machine translation? Again, it is text generation. So this I want to translate it into Kannada. I want to translate this into Tamil, Telugu. That is the new data it is there, or the new text. It is not the same words, right? The words which have the similar meaning in some other language, right? So these are all text generation. The ChatGPT, what does it do? It generates text, right? So there are so many such applications which are used for natural language generation. So NLP mainly concentrates on natural language understanding and natural language generation. Okay, so coming to a typical text. This is a text, right? What is there in this text? If I remove these bullets, what is there in this text? Paragraph, right? You can say so many sentences or so many, let us say paragraphs first, document. If you consider this as one document, in a document we have so many paragraphs. Maybe if you consider it as a book, we can say there are chapters, and in a chapter there are paragraphs. In a paragraph there are sentences. In a sentence there are words. In a word, characters. Now we have another concept which is called as a subword. Subword also may be there. What is a subword? Subword is the analogy is similar to string and substring. String and substring. In a string, the Mangalore, M-A-N-G-A. M-A-N-G-A is a substring. Man is a substring. G-A-L-O-R-E is a substring. So subword is similar to what we have between string and substring. Between word and subword we have similar. Only thing is there should be a contiguous letters. And in Mangalore, man is a subword. Galore is a subword. Why do we need this? We will come to that later. Right? So each word may have subwords and characters, or maybe characters. It depends on, especially this is used in now there is a tokenization which is called as subword tokenization, and subword tokenization is a very popular method which is used to overcome out of vocabulary. What is out of vocabulary? I mean, if you we have so many foreign students here, definitely I do not know their vocabulary, at least their language vocabulary, or even people who speak Tamil are there. Maybe I know few words, but if you say some word, I do not know that word. Right? Similarly, if I say some word, you do not know that word. So it's not in my vocabulary. It is as simple as that. Out of vocabulary says that it is not in that vocabulary. So how to deal with this out of vocabulary problem? So subword tokenization is one example or one way of dealing with out of vocabulary problem to some extent. It may not give 100% solution, but yes, to some extent it solves. What does it do? In the vocabulary, let us say the word Mangalore. In a vocabulary, if Mangalore word is there, then Mangalore word will be used. But if Mangalore word is not there in the vocabulary, then the Mangalore word will be split into the words that are there, the smaller words which are already there in the vocabulary. So man may be in the vocabulary, galore may be in the vocabulary, man. If man is not there, an is a word. So that is where this subword tokenization or subword helps. But if you see individual characters, it may not say anything. If you consider individual words, it may not carry, like bank. What do you mean by only bank? If I say bank, if I say Mangalore, if I say university, they may not convey. But put these together, definitely they convey meaning. In fact, they convey a lot of meaning, right? Okay, so we speak words, we use words, we write words, right? We do a lot of things with words. So what is great about words? Right? A word is comprised of, say, a lot more things are associated with words. A word has a meaning. There is a syntax associated with a word. A word is comprised of phonemes, graphemes, morphemes, etc., etc. Right? A word is comprised of alphabetic, and word is having a script also. So, does English have a script? English is the world's the most popular language. Does it have a script? Yes, English doesn't have a script. English uses Romanized script or the Latin script, right? The A, B, C, D. That is not English script. English does not have a script, right? Even though it is the most popularly used language, official language of many countries, spoken by. I mean, English is the first, the top language that is spoken by many individuals, right? If you rank, English stands first, but it's not having a script. So that is the Roman script. Right? So script is also very important. The local language Tulu has a script, Tigalari, but that is not popular because people are not using that. So instead they write it in Kannada. So the language is Tulu, but they use Kannada script. Similarly, the language is English, but they are using Roman script, right? So many things are associated with words. What is great about words, right? We study words, we understand words, we use words, we absorb words, we are enthusiastic about words. Atma Nirbhara Bharat, right? So only, I mean, since a few years we are listening to that word. Earlier that word was not there. Lockdown has got a different meaning earlier. After COVID, the meaning of lockdown is different. Mask had got some other meaning. Now the meaning of that mask has changed. So we are enthusiastic about words. We are sanctified about the words. That means a kind of blessed or kind of sacredness. We are blessed by the words, and that's why our elders say, be careful when you are choosing the words. Words have got the power, right? Words have the meanings. Words has got the energy. So try to use the positive words. And not only this, in spite of so many words, many a times we feel short of words. We say, I'm not able to get that right word. It is here, but I'm not able to recollect that. I'm not able to speak that word, right? So many a times we also fall short of words. Right. So now let us get into the text processing. What do we do in text processing? Or maybe we can say, what are the requirements of text processing? Let us say some text data is available. What do you want to do with that? You want to develop some application. Let us assume that it is a sentiment analysis application, right? So you need some application at hand for which you want to develop let us say a Python code. So sentiment analysis, or it could be fake news detection, it could be hate speech detection, it could be word sense disaggregation. Take anything, but we need an application. Right? There should be a motive, right? There should be an objective. Without motive, without objective, we don't do anything. The objective may be the silliest of the silliest, but still there should be a motive, there should be an objective, right? Where do we get the data? First we have to get the data, that is the corpus. Where is the corpus? I mean, there is no dearth for text data. We have news articles, we have tweets, we have social media comments, we have digital libraries, we have email, Enron dataset is there for email. Then so many datasets are there, right? This is the corpus, and next comes the dataset, because corpus cannot be used directly. You had to annotate this if you want to use it for classification purpose or supervised learning. Then the text data set format will be like .txt, .csv. TXT, you know, it's a plain text. CSV is comma separated value. TSV is tab separated value, or it may be in a JSON format, or it may be JSONL format. What do we do with this? You have to pre-process. Why? Real world data always comes with noise. Okay, what is noise in text? What is noise in text? How you can build noise to text? I mean, even if, when you consider an image, we say the image is blurred, right? The image is blurred. You can add noise to that image. Put some dots here, or maybe if you can sprinkle some water behind it, or sprinkle some mud or so and take the photograph, right? The noise is there. But what is noise in text? How do you say? Because see, what you have is only words, right? What you have is only words. So what is noise in text? Yeah, whatever may be the data, when you say real world data always comes with noise. So can we remove the noise or text cleaning? And this, it depends upon the application. So if the application is, let us say, sentiment analysis, numeric information may not play much role, may not be required. So we remove that. Punctuation may not give any information. We remove the punctuation. Not only that, if you consider social media data, nowadays more than text we use emojis, right? Do we need those emojis? It depends. If the text data is small size, then you can convert that emoji to text and use them as any other words. But if text data is very large, then we don't need those emojis. You can remove that. And now whenever again, and most of the time the applications that we having now, they are related to the social media comments. So I am referring to those comments. Now whenever we post a picture, we use that hashtag, right? So do we really need that hashtag? Do we really need user mention? If I have to write a message, I'll say @Shashi, that is there, that will be there. Then your text may contain URLs, your text may contain hyperlinks. So all this can be noise. You remove all that. Why we have to remove all that? If you consider, let us say this one, if you consider this as, let us assume that this is one document, this part is one document, this is another document, this is another document, and let us put these two into one document. So now there are 4 documents, right? There are 4 documents. What do we have in a text? Words. And if you go to the lowest level, we have characters. Let us not worry about subwords. We have characters, and characters taken individually does not give much information, right? So word is a, in that case, word can be considered as the basic unit of basic token which conveys some meaning. Character may not convey the meaning. If you consider this, each and every word is a feature. Now you can imagine the size of the text data. Right? Have you heard of curves of dimensionality? Curves of dimensionality. What do you mean by curves of dimensionality? What happens if the dimension is more? What do you mean by dimension? More variables, more features. If there are more features, then you are capturing more information, more characteristics. But more features also leads to computational complexity. Computational complexity also increases. Storage capacity also is required is more. But nowadays storage may not be a major criteria, but definitely computational complexity increases. Not only that, if you consider each one here, if you consider this one, there are less repetitions, right? So how many times and is present, you can check this. And is present once, or is present once, in is present once, like this. Because each and every word is a feature, the representation that we have will be sparse matrix, right? Not only that, on one hand you have larger dimension, higher dimension. At the same time, the feature representation what we have, that will be a sparse, and unnecessarily you are processing 0 values. What is a sparse matrix? There are more number of zeros than the non-zeros. So that is text pre-processing. Yes, then comes the text representation. That is how we are going to represent the text. or text representation, or you can say the features. Okay, we will come to this features. Why features? I mean, I can understand text, you can understand text. Can the machine understand text? No. Data mining. Data mining requires data in numeric format. So convert this into numeric format. And of course the algorithms. The algorithms depends on your application, whether you want to do word sense disambiguation or do text clustering or do text classification, the same algorithm will not hold good. Right? Word sense disambiguation, a knowledge based approach. Right? We need the knowledge sources like WordNet or Indo-WordNet to find out the word senses and the gloss, etc. The same algorithm will not hold good for text classification, and that algorithm does not hold good for text clustering. So it all depends on what is the application that you are going to solve. Sorry? Indo-WordNet is it's like an Indian version of WordNet. WordNet is a large lexical database. Indo-WordNet is for Indian languages. I think it supports 11 languages. Okay, so text pre-processing is this: remove the noisy data, the markups, HTML, XML, punctuation, all this. There will be header, footer, all those. I mean, these do not contribute much to the text processing, so you remove all this. Normalization, one type of normalization which I already mentioned is the expansion. For example, contractions: isn't, didn't, couldn't. You have to expand them. They are called as expanding the contractions. One thing I mentioned is the dimensionality, right? Text dimensionality is too large. It's very high dimensional. How to reduce the dimension? This pre-processing will reduce nearly 15 to 20% of the dimension, and that's why we do pre-processing. So what do you mean by normalization in this context? Stemming and lemmatization. For example, here we have splitting, right? We have sentences, phrases, right? Then converting, meaningful. So remove the suffix, right? Remove the suffix from this meaningful, it becomes meaning, right? Remove the suffix from converting, it becomes convert. Remove the suffix from splitting, it becomes split. Remove the sentence, remove the yes from sentence, it becomes a sentence. Removing the stripping the suffix, or it may be even a prefix also, but most of the time it will be suffix. That is called as stemming, right? Removing the prefix and the suffix. Why? One thing is you have to reduce the dimension. The other one is if you have both meaningful and meaning, both are related. Because both are related, what we can do is you can now we have meaning will be one word, meaningful will be another word. So there will be two dimensions. Instead, you remove meaning, you remove this full from meaning, so now it becomes meaning is present twice, right? Then we have lemmatization. What is lemmatization? Most of the time when you remove this suffix, computers, what is the root word of computers? Compute, right? But when you strip this from this computer, you have to get compute. Right? If you do not, sometimes we do not get compute, right? Studying you should get STDUYING, but removing the ing always does not give the root words. That is why I said suffix stripping. When you remove the suffix, whatever that you get may not be a valid word. But if you get a valid word, now we call it as lemmatization, because you are reducing the word to its base form or the root form, or to its lemma, right? That is lemmatization. Again, why do we need stemming and lemmatization? To reduce the number of words, because each word is a feature, right? Then we have frequent words. Okay, what do you mean by frequent words? Why frequent words have to be removed? Why frequent words have to be removed? When we say features, one thing that you have to remember is we need distinguishable features, right? We need distinguishable features. Let us say a feature is present in all the samples. It could be image, it could be video, anything. A feature is present in all the samples. Can we use that feature to distinguish between the classes? It is present in all the classes, right? The frequent words. So frequent words are those words which are present in most of the samples, most of the documents. It does not contribute much. Not only that, rare words. Rare words. Let us say a participant has come only one day. Do we consider that person as a participant? So rare words may not contribute. Other than this, we have something called as stop words. What are these stop words? If you look into this part, or even when you write something, we have words like the, then, there, why, what, where, are, this, that, of, if, so many words. These are not the content bearing words. These are called as functional words or the stop words, and stop words do not contribute. Our intention is to reduce the dimension. Stop words do not contribute. But when you are using deep learning approaches and the language models, we do not remove stop words. That's why I said pre-processing depends upon the application and also which type of models you are going to develop. Let us say you want to represent a sentence, entire sentence. If you want to represent an entire sentence, then there is no need to remove the stop words. If you want to represent words, what are the features? Okay, in the next slide, I think I have what are the features. Right. So text representation or the text features. So what are the what features we can have? Right. The features are word can be considered as a feature, or character, or if it comes to Indian languages, character won't help. Characters for Indian languages will be the number of keystrokes. If you write Kannada, how many characters we have? 1, 2, 3, 4, 5, 6, 7 characters we have. How many characters? What do we want? But if you check the length of this, it is not 3. It will be, no, not 4. More than that. You can check that. Right? This is because we have this. We call Vattakshara. Right? We have this character. Right? So, for any Indian languages, in the native script, right, character will not be a good representation. So, for Indian languages, we need this syllables. Otherwise, any language which is using Romanized script, we can use a character representation. And the other one is the n-grams. So, what do you mean by n-grams? N-grams can be applied for words as well as characters. N-grams is n contiguous characters. Word n-grams are n contiguous words. For example, if I consider this discrete text representation, or maybe, okay, here we have, okay, let us consider this as one sentence. Process of converting raw data into meaningful data. This is a text. If you consider word unigrams, uni means one. Process of converting raw data into meaningful data. So you will have 3, 4, 5, 6, 7, 8 words will be there. Word bigrams will be like this. Process of converting raw data like this. Trigrams, for trigrams, this will be the trigrams. Process of converting. The same thing you can apply for character. For example, if you have process and unigrams, PROCESS. Bigrams, we have PR, RO, OC, CE, ES, SS. Trigrams, PRO, ROC, these are trigrams. And n-grams play a major role. Why?
Because they will data full word.
FDP, what does FDP stands for?
Faculty Development Program.
Yeah, now you remove that, you make it as 3 different words.
N-gram is one word.
No. Faculty Development Program is 3 words, it's a phrase, right? Instead of 3 words together, you separate the words. Faculty Development Program. Does it convey FDP?
No.
Artificial intelligence. Right? World Wide Web. Mangalore University, Department of Computer Science. So there are some phrases where when they are put together, they give a meaning. When they are separate, they give a different meaning. Faculty Development Program. You can say it is a 3-word gram. But if you, instead of that, if it is not a 3-gram, then it will be faculty development, it will be a unigram. Right? So faculty development program is different from faculty development or development program and or faculty development program. So some applications, I mean n-gram is a suitable representation or a suitable feature. Right. So we have two types of representation. One is discrete representation, discrete text representation. The other one is distributed text representation. And what we use here or what we call this is traditional word vectors, or these word vectors are based on the frequency. So we have two models here. One is the binary weighing measure, and the other one is the frequency weighing measure, or we have the TF-IDF. TF-IDF, which makes use of vector space model. Have you heard of it? By Salton. Vector space model. It was somewhere in 1972. Right? Vector space model by Salton is still being used. So we have one document will be represented as one feature vector. So what happens in binary features? We see whether a feature is present or not. If a feature is present, it will be represented by 1. If a feature is not present, then that will be represented by 0. But binary may not be a good measure. Why? During festival seasons, if you go to supermarket, they say if you buy 2 kgs of sugar, then you'll get 100 packets, 100 grams tea powder, 100 grams packet tea powder free. Right? Where are we giving importance for the repetition? So that's where we have this frequency weighing measure. And if you have frequency weighing measure, there also is a limitation. Let us say you are asked to, last day you have the exam, right? Let us assume that it's a descriptive exam, right? So some of you may write only 3 lines, but some of you may write 3 pages. Who will get more marks? 3 pages, right? Why? I mean, there should be some, the understanding is that, or the assumption is that in that 3 pages, somewhere the answer may be hidden. Most of you are teachers, so it's not a new thing. Now the situation has come where like we may have to dig the answers in whatever the students have written, right? So obviously we will be biased towards 3-page answer, right? To reduce that bias, we have this IDF, inverse document frequency. This frequency weighing measure and this term frequency, they are more one and the same. Only difference is whatever is the frequency, you divide it by the number of words in that document, that gives the term frequency. I'll come to that. I have a slide on that. We'll come to that. Okay. Then the other one is neural word vectors, or the prediction based word vectors, right? And they are also called as distributed text representation or continuous text representation. Again, here we have words, characters, syllables, subwords. Not only this, you can even have sentences here. You can have sentences, you can have document. Document may be a feature. Sentence may be a feature. Finally, what we want for a document? If there is an image, what do we want for that image? We want a feature vector, right? That image has to be represented as a feature vector. That video has to be represented as a feature vector. The speech signal, speech sample has to be represented as a feature vector. A document has to be represented as a feature vector. Entire document can be considered as one feature. Inside a document, there are so many sentences. The sentences can be considered as a feature. Inside a sentence, there are words. Words are considered as a features, right? Words can be considered as features, syllables can be considered as features, subwords, n-grams, all these things, right? So here in this one, this is for the document representation, or you can say the text representation. But this distributed text representation is a word representation. For a word, we have a feature vector. So now if there are 5 words in a sentence, how do you get the feature vector for that sentence? Here it is not so. For a document, you will get 1 vector. But in this case, these are word representation models. In word representation models, for a word, there is a feature vector, right? Discrete text representation, the dimension is more, it is sparse, right? Dimension we do not have control over that, but distributed text representation, it's a low dimensional vector, and it is a dense representation. It is not a sparse representation, it's a dense representation. But the thing is, this representation is for a word, not for a sentence. So what do you have to do to get the representation for a sentence? Max pooling, average pooling, something that like that we have to do. So let us say there are 5 words. Neural, okay, let us consider these two itself. We have text and features, right? For a text there is a representation, for a feature there is a representation. Put together, add it, add the corresponding vectors. You have a, what you have done now, you have summed up, that is one representation. Or take the average, that is another representation. Or take the maximum, that is another representation. What do we have now? Now if these two put together is one sample, one document, now we have a feature vector for that. That can be extended to a document of any size, right? So by having the representation for words, you can create a representation for a sentence. By having the representation for the sentences, you can create a representation for a document, right? Then we have pre-trained language models. What is a language model? A simple example, I am going to dash. I am going to dash. How do you feel that? I am going to dash. Fill that. I mean, fill with whatever you want. I am going to movie. Okay, I am going to beach. I am going to school. I am going to bank. You can, I mean, use whatever it is. What does the language model do? I mean, in simple terms, I am trying to convey this language model. What does the language model do? How the language model is built? Language model, of course, it's a neural network model. Language model considers large amount of text. The Wikipedia dumps all possible text sources, right? They'll consider all possible text data and they'll find the probability, right? Or it can be somewhat similar to the next word prediction. Language model predicts the next word. Or what is the probability of the word school appearing there, right? For that, what we need? In the corpus, let us assume that the word beach is not there in the corpus, in the entire corpus. The word beach is not there, right? If the word beach is not there in the entire corpus, the language model may not say, I am going to beach is correct. It will not predict beach. Or if you say, I am going to beach is correct, the language model may say no. Why? It doesn't know about beach, right? So in a very simple a layman approach, if you consider, language modeling is it predicts the next word. And which word has to be there? The word which is having the highest probability. It can be a word or it can be even a phrase. Having the highest probability will be in that gap. I am going to beach. Let us say beach has appeared some 10,000 times. School has appeared 10 times, right? So beach will appear there. Why? Because the probability of school coming there is less compared to the probability of beach appearing in that sentence. So in simple terms, language modeling is, it's a probabilistic it's a probabilistic model. It gives the next word, right? So for pre-trained models, for word representation, you cannot use sentences or documents. For pre-trained language models can be used as features. Some of the pre-trained models, they also offer the text processing tools like classification, summarization, tokenization, right? So many other things. And for pre-trained models, we have GLOW, fast text, word to vec, BP, byte pair embedding, FLAIR. Again, you can have the list. Not only this, we also have domain specific, these are called as pre-trained models or word embedding models. And all these word embedding models started with this word to vec. Word to vec, when Michelot started in 2013. This was the first pre-trained model. So after this, after 2013, maybe for the last one decade, The growth of NLP is so much that maybe whatever was lagging behind, whatever it was like something was blocking the growth of NLP. Now everything has done together. It is what is that? It is progressing in such a vast extent. Not only this, based on this, even for the under-resourced languages, the low-resource languages, people are trying to build the models. For Tulu, we have the fast text model, where the vocabulary is only 7,000. Instead of 0, we have something. From that, you can build, right? This byte pair, all this. GLOW has only English, I think. Fast text models are available for 157 languages. Right, then we have BP, byte pair embedding. Several Indian languages are there in this byte pair embedding. Right, then language models, we have this ELMO, ExcelNet, BERT, BARD, DistilBERT. Mural is for Indian languages. There are more than 100 languages, I think. Same BERT. Yeah, this is BERT, transformer representations or the transformer model. So these are all these pre-trained models, they are also called as transformer models, and this is not a limit. I mean, these dots say that many more, it goes, many more are there, and now we can have domain specific transformation models or domain specific language models, and you can convert your own language model, right? Only thing is you need large corpus. If you do not have large corpus, don't worry, whatever corpus you have, for that you can build. Not only this, even this one, GLOW, fast text, word2vec, anything, right? And some of these are some of these do not consider the context, right? They are context free. Whereas this ELMO considers the context. This GLOW, word, see these pre-trained models, they are like a large dictionary. What does a dictionary consist of? This dictionary, you have a word. Let us say apple is a word, right? What is the representation for this? What is this? These are numeric values, right? If you consider TF-IDF, there will be a lot of zeros. Here there won't be zeros. It will be a negative value or a positive value, but there won't be zeros. And what is the size of this? They come in standard sizes. If you are using the pre-trained models, they may come in 100, 300, I don't think even 500 is there, these models. But all BERT models, dimension is 768. It does not cross 768. But if you consider TF-IDF, the size goes, I mean 1000, 2000 is nothing. If you have a document, something like 10,000 documents, then easily it can cross 20,000, 30,000 words, because I am saying 10,000 documents. So 20,000, 30,000 words is common. And not only that, that is sparse, but this is not sparse, this is dense representation, right? But the thing is, it may not consider the context. That means to say, let us say if you have, if this apple is present in two different sentences, maybe one with apple as a fruit and another one with apple as an electronic gadget. If you consider GLOW or fast text or anything, then we'll get the same feature vector or same word representation. But if you consider ELMO or BERT, then we'll get different word representation. It is not the same word representation. Okay. Coming to the representation part, all of you must be using label encoding. Label encoding for classification, that is called as one-hot encoding. And one-hot encoding, of course, is not a good representation for features. So this is the encoding space. These are the three documents. 1, 2, 3 documents are there. So this is the encoding space. You can see this is the first document, second document and third document. And let us see how these are represented. So here I am showing the representation only for the first document. The second and third document, we have to build 2 more vectors like this. This representation what we have is for the first one. This is a binary representation. You can see the is here, elephant is here, sneeze. You remember we have done stemming now. So sneeze, there it is sneezed, but here we have sneeze. D we have removed, suffix stripping, right? So sneeze is here. Then at is here. Stop word has not been removed. The is already there. So the is the cannot be present twice. This is an vocabulary, it is a set. So set of all unique words in the entire corpus will form the vocabulary. So repetitions are not allowed. Then the twice, sight we have here, of we have here, potatoes we have, potatoes, es is removed, so we have potato. This is the binary representation. Binary representation for one document. How many sentences are there? Three documents, right? Here you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 words for just 3 documents. Now you can imagine the size of the document, something like 10,000. Because 10,000 documents is nothing, right? So this, and another point that we have to consider, remember here is, this will be the size of the feature vector will be the size of the vocabulary. Vocabulary is nothing but how many unique words are there in the entire corpus. Right? This is a binary representation. See here, the is present twice, but we are not giving importance for that. I mean, remember that during festival season, if you buy 2 kgs of sugar, then you will get 100 grams tea powder free. I mean, even if they give 50 grams free, that's fine. We have to give importance for that. So that importance is not given here. Right? Now this is the representation for the second one. Here you can see 2. This is a bat, right? This is bat, this is bat. So if you remove yes from this, this also is bat, this also is bat. So we have the frequency representation 2. Right? Again here C. This is one C, this is another C. So frequency representation. What is term frequency? Term frequency, how many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words are there. Divide this by 10. Right? Divide all the non-zero values by 10. 0 anyway will be remain 0 only. The rest you divide it by 10. Why 10? Because there are 10 words. That becomes a term frequency matrix. Here. Yeah. It says whether it is present or not, binary representation or Boolean weighing measure. Second, this is the frequency representation. In frequency, I mean, you remember that example. If you buy 2 kgs of sugar, you have to get 50 grams tea powder free. So we are giving importance for that. So repetition is given importance here, right? So term frequency is that you divide this by the total number of words. That gives a term frequency, right? Again, this is not a good measure. Why it's not a good measure? 3 lines versus 3 pages. 3 lines versus 3 pages. So if there are 3 lines means number of words are less, right? Answer also will be less. 3 pages means number of words will be more. So obviously we will be biased towards 3 pages answer. That has to be normalized. And that is where we have this inverse document frequency. What does inverse document frequency say? It counts in how many samples a word is present, not how many times. In how many samples it is present. If a word is present in all the samples, that is of no use. Frequent words will be removed. If a word is, let us say it is present in only 1 or 2 documents, it's a rare word, that also will be removed. Right? So here, in how many documents a word is present, that will be given importance. So this is a normalization. This is the first step towards normalization. What is normalization? So our students, I mean, in a semester, if you are having 5 subjects, 500 total marks. So how many unique values will be there? 1 to 500. 1 to 500, right? Now, if I ask someone, how much marks did you get? Someone may say 450. 1 to 500. Someone may say 78%. So we are reducing the funnel approach. When you are reducing, or the V shape, when you are reducing, 1 to 500 will be mapped to 1 to 100. 1 to 500 will be mapped to 1 to 100. Right? And that can be further reduced. Instead of that, we can even have grades. Right? So normalization is bringing down the data into a uniform format. Right? So here we have. So we have TF. TF, I said how you measure TF. You multiply this TF by this IDF. IDF is for the given collection. TF TF is for each and every sample. For if this is one sample, if this is one text, for this we will have a TF. This is one text, this is a TF, this is a TF. And for all this TF we have only one IDF, because IDF will be for the document collection, not for the document. So multiply this TF by IDF. I mean, it is like one-to-one multiplication, right? So that gives TF IDF. And even today, TF IDF is a popular representation for text data. And this is the handcrafted feature. This is not automatically extracted feature. This is a handcrafted feature. And even today, TF IDF is being used. Yes? Dimension? Same. This is TF IDF. Okay, this is TF IDF. Here you can see this is 0.3, this is this is for the third sample now, right? This is 0.3, 0.3, 0.3, 0.4, 0.3. Okay, dimension, Boolean weighing measure, frequency weighing measure, TF IDF, dimension is the same. Dimension is equivalent to the number of words in the vocabulary. That does not change. That comes later. First, this is the basic representation. So first we want to have a representation. So once we have this, then we can think of feature selection mechanisms for this. So TF IDF as it is, but okay, I mean now everyone is using Python, right? Python libraries are so vast that if you keep on experimenting all the Python libraries, maybe one life is not enough. At the same time, Python is also making us lazy, because we are not using our intelligence. We are not, we do not want even to code, right? So TF IDF vectorizer is there in sklearn, scikit. TF IDF vectorizer there, you can put a limit. If you want top 300 features, you can say, just say maximum number of features is 300. You'll get the top 300 features. I mean, that depends on the implementation. But otherwise, this is the TF IDF. Okay, in distributed representation, I do not go into this detail, but what is the drawback of this? Let us say, what is the difference, what is the relation between good, better and best? Do they convey more or less the same meaning? Good, better and best? At the highest level of, not the, may not be the exact meaning, but when you say good, better and best, yeah, but all the three say good, right? It does not say bad, right? Okay, can we use good and best interchangeably, at least in some cases? Synonyms? Yes, but TF IDF doesn't do that. In TF IDF, if one document is having good and if the other document is having better, good is not the same as better. Why? Because TF IDF does not give importance for meaning. There is no syntax, there is no semantics, nothing. It's only for keywords. It's based on the, not even keywords, we say content words. Right? It is content words. The other one is, I mentioned about bag of words approach. What is bag of words? We have removed punctuation. When we remove punctuation, what we have? We have collection of words. So put all these words into a bag. Right? Let us assume that these words are some physical entities. Right? Is there any relationship between one word and the other word? There is no dependency. If you remove all the punctuation, right, and if you consider them as unigrams, there is no difference, right? Sorry, there is no, the dependency is not there. There is no relationship between one word and the other word. That is the drawback in TF IDF. Even though TF IDF is one of the popular representation, it gives importance only for the keywords. So good and best, they are not related, but good and best are related. If you measure the semantic similarity of good and best and good and bad, which are the two words which are near, which are similar? Whether good and best are similar or good and bad are similar. Good and best are similar. That importance is not given by TF IDF. Right? Then TF IDF, the other thing, it's high dimensional, it is sparse. So all those things are there. Right. So cannot compare documents that don't share terms. If the documents share terms, then only we can say, I mean, there should be the same keywords. If the keywords are different, then it's like totally different. So all these things have led to the distributed representation. And what happens in distributed representation, you can see here. This is for the first one. Do you remember? Earlier the dimension was 18. Now the dimension is 1, 2, 3, 4, 5, 6, 7. Right? And this 7 is not for each word. This is not for this is not for elephant, this is not for seas, no, not that one. For this, the elephant sneezed at the sight of potatoes, this is the representation. And if you consider this, even for this you will get a vector of size 7. I mean, there won't be a vector of size 7, this is only for the illustration purpose, otherwise I have to consider a vector of size, minimum will be maybe I think 100, 300, but not more, definitely not more than 300. But all BERT models, they have 768. The vector size is 768. Sorry? Yeah, I'll come to that. Okay. These are the examples. Sorry, not Elmo. Glow, word2vec, fasttext, these are the examples. Okay. How do they arrive at this value? I said they are the word representations. Right? To get this value, what do? We need large corpus. Right? Large unsupervised data, not supervised data here. We need large unsupervised data, and based on that, they build these models. I have that, I'll show you. Okay, this is the overview. Okay, this is what we have. One is a continuous bag of words model, the other one is the skipgram model, and these two are like opposite to each other. So what happens in continuous bag of words representation is, here you can see the context window. So if this is W0, two context window says that W minus 2, W minus 1, this is 1 and 2. Right? Given the context, these two are the context. Given the context, you have to find out the target word. Or given the target word, you have to find out the context. That is the skipgram model. Right? There are basically two models, and this is called a predictive embedding model. And this journey of word embedding started from this Michalov. Michalov in 2013, that was the first word2vec model that was developed. This is dense representation, a low dimensional vector space, right? Dense representation says that there are no zeros. It's not a sparse matrix. But what if we have is like this. Now apple, we have a 300, we have a 100 size matrix. Bat, another matrix. Exactly like a dictionary, but or a lookup table. But what we have in this, apple means this one. What do we do now? Whenever we are having apple, if you want a representation for apple, get this representation. Right? Get this representation. Let us say I have apple fruit. I want this. What do? You take the representation for this fruit. Right? Now you add these two. Add these two. Right? If you add these two, this is your summing. So usually we do not sum it. What we do? Divide by 2. What happens? Divide by 2? You are averaging. I mean, here there are 2. In fact, if you add, let us say, bat here, then you will have another one. Then it will not be 2, it will be 3. Averaging. You take the average. Now, this is for, not for bat, not for apple, not for fruit. It is now your document. Let us assume that you have removed all the stop words, you have done stemming, everything, punctuation, everything. These are the 3 content words. Now, here we have bat, apple, fruit. For this, we have either 100 or 300 or 200, whatever is the size that is available. The pre-trained models are available in standard sizes. But if you want to develop your own model, then you can have your own option. You can have, instead of 100, you can have 50, instead of 300, you can have 500. Anything can be done here. Okay. Then comes the pre-trained models. These word embeddings, they are like static. You have a dictionary, right? If you consider a dictionary that is published yesterday, let us say the hard copy, can you add more words to that? No. It is already published, right? You cannot add more words. You cannot even remove more words. It's a static copy. The word vectors, the pre-trained models are like that, static copy. They are not, they are not updated. They cannot be updated because it needs vast resources for updation. Moreover, they are not updated. Not only that, data drift, when Dinesh was mentioning, he said data drift. There may be data drift. What was the meaning of lockdown prior to COVID? And what is the meaning of lockdown now? And I have heard of trend, sometimes we say this is the trend now, this is the fashion now. That applies everywhere, right? So whether this word to vec captures the new meaning of lockdown may not be. And whatever words, as I said, yesterday's dictionary is already published. Let us say today there is a new word that is not there in the dictionary, out of vocabulary, right? That defines out of vocabulary. Okay, so these things led to pre-trained language models. I already have mentioned language models. Now you are adding pre-training component to that. That means you are pre-training the language models, where we have the concept of transfer learning. We are pre-training and then making use of this for a similar task. Anything, classification, for various things it can be used. So this is the concept of transfer learning. Okay, now the question is, why can't we have our own embeddings? I mean, that's what people are doing. Let us say, for Kannada, there is no, I mentioned about syllables. What is a syllable? If you say, if you write Kannada here, this is one syllable, this is another syllable, this is another syllable. So there is no concept of syllable embedding so far. Right? We have started at syllable embedding. There is no, there are no papers on syllable embedding. In fact, we have not yet published the syllable embeddings which we have developed for Kannada and Tulu. But we have taken a prototype of that and we have made use of that, and we have just mentioned that we have created and used, but we have not yet published that. So similar to that, can we have our own embeddings? What is the problem? Infrastructure may be the problem. Right? Corpus may be the problem. We need large corpus. And what we have, these pre-trained language models, they are for the general domain. Yesterday, if you remember, I asked one question. So there is a lot of difference between pre-trained models and domain-specific models. And most of the applications are domain-specific. We cannot have one application which takes care of all possible tasks. All the applications are domain-specific. Right? There is no generic application. But we have general pre-trained models. Sometimes for some applications, general pre-trained models, they perform better than the domain-specific models. For some applications, domain-specific models perform better than there is no rule that this is the best model. Similar to say, can we say that this classifier is the best classifier? No, it may give good results for a number of applications, but always we can find one data set for which we get not good results, or we may get even the worst results. So we cannot say this is the good classifier. Similarly, when it comes to feature, this is the best feature. How do you say this is the best feature? In our experience, in the experiments that we have conducted or in the experiments that other people have conducted, this has given good results. Right? Has someone reported using the same features they have got the worst results? Possibilities are there. We cannot say this is the best feature, that we cannot say. Similarly, classifier also, this is the best, no. What we can say is, over a number of applications, we are giving good results. We are getting good results. There may be an application, there may be a scenario where we are getting even the worst result. Okay. Why cannot we have our own embeddings? Corpus collection itself is a problem. One of my students is working on machine translation. At that time, we didn't realize, while framing the objectives, we didn't realize that corpus collection may be that difficult. Right? People are not ready to give the content. There are several writers, Tulu writers are there. But whenever we approach them, they always say, they have they are afraid of giving the data because they think that we will publish that, we will plagiarize that and we will publish. So they are not ready to give that. I mean, it's not an ethical kind of thing, but they are not ready. We tried convincing them, but no, they are not convinced. Right? So sparsity of the training data, corpus itself may be not available. Right? Then large number of trainable parameters. The trainable parameters I am not going to touch, that you know very well. But if you can solve these two, right? Let us say I have this laptop. Using this laptop, do you think I can build a BERT model? I mean, if this is the only resource that is available, definitely I have the infrastructure problem. It may not be possible. I can use Google Colab, but Google Colab also has restrictions. So this kind of problems are there because even on the best, what do you say, the best lab, some models they take several hours, some models that even take several days in spite of all that GPU, TPU, everything. And what you can expect me from this laptop? But you can always experiment. You can construct a small model, right, and see how it works. Because whatever that holds good for bigger model holds good for a smaller model. Only thing is the vocabulary is smaller. Right. Then what we need? We need the algorithms or models. So if you are using machine learning, then we have, I mean, this is with respect to the classification problem. We have SVM, decision tree, logistic regression. I mean, there are a number of classifiers which we can use. And if it is deep learning also, then we can use. See, for example, BERT. BERT acts as a, BERT can be used for feature extraction. BERT also supports classification. There are models like that. Okay, this is the overview. We have bag of words, TF-IDF. Tokenization. Tokenization is splitting the document or splitting the text into meaningful units, whichever unit you want. Do you want one document as a feature? Yes. Sentences, split, do sentence tokenization, word tokenization, character tokenization, subword tokenization. It depends on what you want. Time, Aita? What's the time? Okay. Okay, fine. So this is the overview. Okay, I'll skip this. I mean, the agenda is this. Okay, I'll take few minutes, that's all. Okay, you can attach NLP to a number of domains. So we have clinical NLP, biomedical NLP, medical NLP. You can go on adding this. So what can you do with this, or what type of applications or problems you are expecting? Word sense disambiguation do we have in medical domain? Named entity recognition in medical domain? Classification in medical domain? Summarization in medical domain? All this can be applied. I think now you got a point why I considered those things. So it is like we have a NLP, a bigger one, bigger umbrella. In that bigger umbrella, now we have the clinical NLP, biomedical NLP is a bigger one compared to your medical NLP or clinical NLP. So clinical NLP concentrates on only the clinical text. Which are the clinical texts? So here we have some examples. So POS tagging is there, entity recognition is there, data normalization. All of you are familiar with the social media language. The clinical text is not different from the social media language when it comes to using the short forms, right? So sentiment analysis is there, data normalization is there, but the very first application when we say NLP or digitization, anything, any technology to do with medical is this one. What is this? Doctor's prescription. Doctor's prescription. Okay. If this is a prescription, I mean, we have the people who can decode this, right? Who is the one who can decode this? Medical shop. Yeah. Instead of prescription, suppose if this is a confidential letter, or it may be a letter written to a friend, where we are sharing some confidential information, right? Then we need, where is the confidentiality then? We need someone to decode this, right? But now we have this. Google helps to read this doctor's prescription, right? But now things are improved, right? This is what we have. What is this? Right? So doctors using technology, and because doctors are using technology, we have is EMR. They said we use EHR is a standard word, electronic health records. But they said EMR, medical records, electronic medical records, right? So, I mean, there is a lot of improvement, right? Okay. So, biomedical NLP, clinical NLP, these are the few tasks. Word sense disambiguation, named entity recognition, relation extraction, machine translation. Why machine translation here? Whatever, see, most of the medical data is in English, right? So I want my data in Kannada. I cannot read English. Machine translation application we can have here, right? Word sense disambiguation. Why word sense disambiguation? See here, what is BK here? Below knee. What is BK? BK is a virus, right? The patient underwent a left BK amputation. BK viremia is the past. So abbreviation is a big headache in medical image, medical data or clinical data, right? CVA. What is CVA? We do not understand what is CVA, right? Not only this. Okay, I have another slide I'll show. This is a named entity recognition. What are names here? Name of a person, maybe name of a doctor, name of a patient. Not only that, we have lot more. We have name of the diseases, right? Name of the treatment, name of the medicine. So many are there, right? So here we have biomedical domain and medical domain. Okay, I'll show you one. This is the type. These are the types of clinical data. You have EHR or EMR, then clinical narrations, which requires medical transcription, and most of the Indians are doing this medical transcription because compared to any other part of the world, Indians speak good English. Discharge summaries, another type of data. Radiology and pathology reports, another type of data. Clinical trials or drug reviews, medical research documents or guidelines, this is another one. Okay, this is the narrative text. How to mine this narrative text? Right? Then this one. Can you understand? It may be next to Morse code language. It's a telegraphic language or a coded language. But we cannot understand. Can the doctors understand? Can the nurse understand? The purpose is served, right? But when it comes to layman, we cannot understand this. Right? So what is this? DC says discontinue. We do not know DC is discontinue. Right? So this is like a telegraphic language. Right? Okay, these are the few challenges. Sorry?
That will be useful for between doctor and
Yeah.
nurses.
Yeah, between doctor and nurses. Assume that a new nurse has come. So DC is discontinue. I mean, she may have a different meaning. So then it may lead to hazards, right? Okay, these are some of the challenges, right? For any word or phrase, assign it a meaning. Meaning from where? Or a null value from the taxonomy. Knowledge resources, right? Taxonomy, ontology, that's required. For word sense disambiguation, if it is English, then we use WordNet. WordNet is the largest online lexical database, which is available online as well as offline. Now, not only that, we also have multilingual WordNet. And a Kannada version we have for 9 or 11 languages. But Indian language vocabulary is only 60,000. A very small and not very curated data also. A lot of mistakes are there. Right? Okay, this is one. Mr. Huntington suffers from Huntington's disease in Huntington. Right? See, this is Huntington. Again, Huntington's. Again, there is another one. Huntington. Mr. Huntington suffers from Huntington's disease in Huntington. Huntington is a place. Huntington is a disease. Huntington is the name of a person. Okay, determine time, location, entity. Summarization, right? Not only that, we mentioned about translation. Given an image, can we get the output in text data? Given an X-ray image, I want the description of that text generation, right? So this is the unified medical language systems. Okay, which one? Might have been done because I said no. I mean, I don't know about medical image processing. Image processing, I mean to ABCD just now. Just started ABCD. Of course, this text part also I do not know. I have not explored much. Right. This is the NER using Spaces. Spaces is one library. I mean, I had included that. Anyway, I can share you this PPT. I have included about a lot of whatever libraries that are available. What are the pre-trained models that are available? All those I have included in the slides. You can check that. Okay, these are the common data sets we have. Direct to patient communication, EHR, insurance claims, prescriptions. I mean, lot more. Again, this is not the end of this. Yes, important. Do we have pre-trained models? Yes, these are the pre-trained models. Cybert, Clinical Bert, BioBert, Biomed Robota. Okay, this Biomed Robota is a domain-specific model. Robota is a generic model. But for most of the applications, Robota gives good results than this biomedical Robota. And again, this is a small list. There may be many more. I mean, I couldn't explore much. These are some publicly available clinical tasks. Right? Not only that, if you visit Hugging Face, Codalab, Kaggle, you'll get lot of data sets, lot of shared tasks. Where do we start? If you do not know where do we start, how to start, then visit Codalab, visit Hugging Face, or visit Kaggle. They'll give the data set, they'll have a computation, they'll also give the deadline, right? And in some computations, they'll also have very good price amount, right? And you can also publish in some conferences. These workshops will be attached to some conferences. They'll publish free of cost in some workshops, or there may be a minimal amount. And in one such shared task for medical, what is that? Medical professional identification, professional's name, I think, something related to this medicine. We got the first place. Right? So publicly available clinical NLP tasks, lot of there. Okay. What do you say about this? We are somewhere in between, right? So today when Dr. Manjunath Chennai was telling, he says, this is helping me, right? This is helping me. This is the AI assisted. This is helping me to take quick decisions, right? But finally, I mean, it depends. It depends on whether we trust the technology or we trust the doctor, right? So this will be the future. So doctors may be, I don't know to what extent they will be replaced by the technology, but definitely it may happen one day. And why it happens? Why it happens? Because see, earlier, even now there are doctors who check the pulse and they'll diagnose without looking at the lab reports. But now there are, I mean, I am not in favor or against anyone, but this is what is happening in the society. But now there are doctors, even if you go with some cough or fever, they'll advise you a list of test, blood test, this test, that test. So what are they trying to do? Where is that experience what Dr. Manjunath Chennai was telling? Experience is here, samples are here, knowledge is here. Where is that? They are relying on that. Okay, but this feature is not too far, right? Okay, these are some of the references. These may be the old references. Okay. Earlier I had included some tasks like sentiment analysis, hate speech detection, fake news detection, etc., etc. This gives these are the two GitHub pages of my students. One Asha is here. I don't know whether there will be lab. If there is lab, she would help you. Then the other one is my MSc student. Now he is about to complete his PhD. He is in some university in Mexico. These two GitHub pages has got lot of codes, right? Okay. So my sincere thanks to my research scholars. I mean, because of them, I am able to explore some new areas. And of course, thanks to Professor Shekhar. I said I don't know anything about medical image processing, and medical NLP has nothing to do with medical image processing. But maybe because he insisted, I could explore this. So thank you very much. Yes. So journey of 1,000 miles begin with a single step. Thank you. And why I have written this is, even if one or two of you can take up some natural language processing work in Indian languages, I feel the purpose is served. Thank you very much.
I express my sincere thanks to Madam Shashireka for explaining in detail natural text processing, applications, representation model, and the processing techniques, challenges, and finally NLP in medical image processing. So today's lab session was supposed to be NLP. Asha and Sharal, they have prepared the code as well as presentation for that. Since we have planned to go to visit what is that Tanirbavi beach. The lab session won't be there, but we will upload presentation and the code that they have prepared in the Google Drive, and the link will be shared by them. So they will share you the link in the Google Drive. Today you can go through it, and please prepare and come for the tomorrow session. Participant presentation. Okay. So now we will have a short tea break, and before that I would like to request Professor B.S. Shekhar sir to hand over memento as a token of gratitude to Madam Shashireka. So we will have a short tea break, 10 minutes. After that, we will tempo traveler will come, TT will come. We will move. Okay. Thank you.